Okay, so let's continue on question 2a. So basically question 2a is just a repetition of the previous RSA calculations, like the first we had on this channel from the test 1, but they are just changing the things you need to encrypt or decrypt. So in this case, question A, 2a says you receive a message which is K. So you need to keep in mind that this is a ciphertext. Everything will be reviewed. So the ciphertext we are having is K, R, K, then C, Q. So that's the ciphertext you have received. That was sent using RSA. RSA public key. RSA public key. So that public key is 21,5. So they are telling us to decode this to find the original numeric and text message. So first of all, we need to understand one thing, that a public key is denoted by N, E. So E for encrypting, because it's a public key. I'm sure by now you know. So from this we can tell that our N is equals to 21 based on this, because we are saying N, E, and our E is equals to 5 based from that. Now what we need to understand is that how do we calculate N? So N is calculated by saying P times Q, like that. So if our N is equals to 21, what numbers can we multiply for us to get 21? So in that case we have 3 times 7, or 1 times 21. But remember, we get something which is looking more unique and as big numbers, not 1 and 21, no, but 3 times 7, like that. So therefore we can tell that our P is equals to 3 and our Q is equals to 7 from that, since 3 is being replaced by P and Q by 7. So we can tell. Now we need to calculate for M. So M is P minus 1 then times Q minus 1. Okay, so we know the value for P, which is 3. So we say 3 minus 1 then times Q, which is 7. So 7 minus 1. Then we do our calculations. So 3 minus 1 we get 2. Then times 7 minus 1 we get 6, like that. Okay, finally 2 times 6 we get 12. Okay, so at least we have the necessary details we need to know now. So next thing we need to do is that we need to list prime numbers. We need to list prime numbers which are less than n. Prime numbers which are less than n, like that. Prime numbers less than n. So our n in this case is 21. So we are saying we need to list prime numbers which are less than 21. And how do we list prime numbers? So first of all, we need to understand that prime numbers is just a number which is divisible by itself and 1. Or in other terms, we can say a number when you divide it by 2, it should give you dot something, point something, not a whole number. So let us start listing. So we'll start at 2, 3, 5, 7, 11, 13, 17, 19. So we end at 19 because those are less than 21. So as you can see, 2 is only divisible by itself and 1, and these following numbers, same issue. Okay, now since we have that, we already know our E, which is 5. What we need to do is for us to find D. So how do we find D? So D has a formula which says ED minus 1, then divide by M. But it has a condition which says we must get a remainder which is equal to 0. Or in other terms, once you compute this formula, you need to get your answer as a whole number, meaning the remainder is 0, not point something. Okay, so our E, we need just to replace. Our E is 5. So where there's E, you put 5. Then D, we don't know D because it's E times D. I'll leave it blank. Then minus 1, which is 1, over M now. Our M is 12 based on our calculations. Now we need to start. We have 5, which is that. Okay, let me do that. We have 5. Then remember the condition, it must give us a whole number or a remainder of 0. So what you need to do is you need to start using these prime numbers by entering them into this blank space where we are representing D to compute this to see if we get a remainder of 0 or a whole number. So I'll start with 2. So we have 5. I'll say 5 then times. So if I put 2 from that list of prime numbers to represent D, it will be 10. Then we have a minus 1, then which is 9. Then we need to divide by 12. So once we divide by 12, we can see that this is not a whole number and it's not a remainder of 0. So D is not 2. So we skip, we go to 3. So we have 5, then times. So computing D by putting this 3, it will give us 15. Then we need to say minus 1, which is giving us 14. Then we divide by 12, which is now giving us that. And you can see it's not a whole number, meaning the remainder is not 0. So our D is not 3. So we go to the next number, which is 5. So here we have 5. So 5 times this 5 we are replacing in place of D, which is giving us 25. Then we have minus 1, like that. We are getting 24. Then divide by 12, which is giving us 2. So as you can see, replacing 5 to represent D from that prime numbers we have, we end up getting 5 times 5, which is 25, minus 1, divide by 12. Then we are getting 24 divided by 12, which is 2. So as you can see, 2 is a whole number and the remainder is 0. So we need to say, therefore, D is equals to 5, because we replaced 5 where there was D in order to get this whole number. So 5 is the value for D. Okay, now, since the question is talking about decryption, we decrypt using the private key. So RSA private, this time not public like that, private key will be N comma D, not comma E, which will be equal to, what's our N? As you can see, our N is 21, our D is 5. So the keys for encrypting and decrypting this time around were the same, like that. So now we can follow up the question. Okay, so remember, we need to decrypt this KRKCQ using this key now, 21,5. So we need to list out the alphabet for it to correspond with certain numbers. Okay, so let's do that now. So I'll just do it from here, like that. Okay, so from this alphabet, K is 11, then we have R. As you can see, R is 18, then we have K again, which is 11, then lastly we have C, which is 3, or lastly is Q, so Q, which is 17. Okay, now since we have that information, we just need to come up with the formula. So the formula, since we are decrypting, we need to get the plain text, which is M. So we were decrypting the ciphertext mod N, like that. So that's the formula now. So the first thing we need to decrypt is K. From this information, as you can see, we have K, R whatsoever. So we need to decrypt K. So the ciphertext for K was at number 11. Then our D is 5, as you can see. From the recent calculations is 5. Then we say mod 21 because our N is 21. So we open up our calculator. Then we need to say 11 power 5. So now this brings us to the things we are familiar with. We are just interested in the remainder with mod. Remember that. Then we say mod 21. Okay, now this is more like saying divide by 21. Okay, so if you divide this number with 21, you just get up to 2 decimal places, which is this. So now after getting up to 2 decimal places, get rid of the decimal places, then you say times the denominator, which is 21 in our case. So now this will be 7,669 times 21, which is this. Then now you need to get the first answer you obtained from that power, then you subtract it from these final ones we have. Then let's see which numbers are similar. So starting at this point up to this 0 and this point up to this 0 are the same. So it's more like 51 minus 49. So which is 3, if I'm not mistaken. 51 minus 49, that's 2. 51 minus 49, so that's 2. So you say 2. Remember, our alphabet ends up to 26, so meaning 2 is within the range. So we say substitution for 2 is B, like that, because we know our alphabet A is 1, B is 2. So decrypting K, we are getting B, like that. Okay, now we go to the next letter, which is R, this. So R was number 18 on the alphabet. So here is our formula again. plain text is equals to C, which is ciphertext power decryption algorithm mod n, like that. Okay, so our ciphertext this time around, which is R, was 18 on the alphabet, if you can remember. Then our D is 5, then mod n, which is 21. Okay, so at that point we need to use our calculator to say 18 power 5. So we have 18 power 5. So we get this answer, then we paste it and say mod 21, like that. So at that point this can mean divide by 21, but we are only interested in the remainder. Okay, so dividing this answer by 21, we get up to 2 decimal places. That's our interest. So I'll get up to .42, like that. Then next step is that we get rid of the decimal places, then we multiply by the numerator, which is 21 this time around, like that. Then we have 8, 9, 9, 7, 9 times 21, like that. So we copy this, paste. Now here we get the first answer after doing the power, then subtract with this last answer we had on our calculations, like that. Then let's see which numbers are similar or are the same. So starting at 1 up to here and 5 are the same. So it's the same as this part, So it's more like 68 minus 59, which is 9, I'm sure. 68 minus 59, that's supposed to be 9, if I'm not mistaken. Okay, 9. So 9 is within the range of the alphabet, which is up to 26. So we say substitution of 9 should give us I, because I is number 9 on the alphabet. Let us confirm. So as you can see, I is 9 on the alphabet, K was 11, B was 2, whatsoever. So that's the meaning, like that. So now let's go to the next letter from that question, which is K again. So because we have the calculation for K, since you need to show that you need to show all this for you to gain full marks, so you need to make sure that you show your calculations. So for K, I'll just repeat the same things we have here, so there's no need for me to panic, like that. So I'm just repeating the things we have because it will be the same things. Okay, so I'm not explaining because it's the same solution. We just need to make sure that we have both solutions for us to decrypt the correct thing. Okay, so you also need to show that you are solving for both cases, because if you don't show for both cases, you won't be given your full marks. No wonder I'm doing this. I'm showing you or now the lecturers want their answers to be, or your answers to be. Okay, so finally we were getting the substitution for that 2 to be B. So there's a step I've missed here. Where is that step? If I miss something? Oh, I've missed this part. So sorry. Okay, so we are done for K. Now we are coming to C. So remember, C on the alphabet is just 3, A, B, C. So that's number 3. So remember, the ciphertext for this C is 3 on the alphabet. So it's 3 power D, which is 5, then mod N, which is 21. Now we can continue. We open up our calculator, then we have 3 power 5, which is 243. Okay, then mod 21, which can be represented as 243 divided by 21, but we are only interested in the remainder. So from that we get up to 2 decimal places, so it will be 11.57, like that. Then we get rid of the remaining with 11, then we say times denominator, which is 21. So now let me show you how we deal with multiplication of 11. So if you are multiplying 11, what you need to do, you need to separate the things you are multiplying it by 11. So you have 21, which is 2 and 1. So you need to ask yourself, what is 2 plus 1? It's 3. So you need to have 3 in between, meaning the answer is 231. 231. So let us prove. We have 11 times 21. 231, correct. So that's the fastest way to avoid using your calculator. Okay, so at this point, remember, we need to get this answer after the power, then we subtract it from our 231. Now 2 is common with this other 2, so it's more like 43 minus 31 to reduce the punching more punching on your calculator. So 43 minus 31, so we are getting 12, like that. So substitution for 12 of 12 on our alphabet supposed to be L. So 12 is L as you can see, if you substitute 12 we get L, so there we put L. Now one more time, we are coming to which letter? Q. So we have Q now. So let us decode Q. So remember, this is the formula for decoding. Like that. So Q on the alphabet is on number what? So as you can see, Q on the alphabet is 17. So we need to say ciphertext, which is 17, power D, which is 5, then mod N, which is 21. So let's open up our calculator. So we have 17 power 5. 17 power 5. So we copy this answer, paste, then mod 21, which is the same as divide by 21. Then we are interested in the remainder. So let's do that. By now you understand these things, no wonder I'm going fast. So we do that up to 2 decimal places. Then at that point just get rid of the decimal places. Then you say times the denominator, which is 21. Then let's see the answer. Okay, so we have 6, 7, 6, 1, 2 times 21, which is this. Okay, copy, paste. Then we need to get that answer after the power, which is this, like that. Then we subtract it from this, which is the answer we had at last. Then let's see what numbers are common. So as you can see, starting from here up to 8 or up to 5, like that, this is common with this up to 5. So it's more like 7 minus 2, which is 5. No need to use a calculator. So substitution for 5 on the alphabet, so that's E. A, B, C, D, E, that's number 5. So we get E. So if you want to verify on the alphabet, E is 5. Okay. So since we were decoding, we wanted to obtain the plain text. So therefore we need to have plain text and ciphertext. So we already knew the ciphertext. So the ciphertext was R K C Q, like that. So based on what we have decoded, the first K is B, then R has become I, not 1 I. Then another K, which was B again, so it's B. Then C became L, so L. Then this Q became E, as you can see, like that, E. So now this ciphertext, which was KRKCQ, becomes Bible. And if you go to church, you are not supposed to fail this question because it's Bible. Okay, so this is Soko James representing KMU Cybersecurity Tutorials. See you in question 2B, where we need to explain some of the block ciphers.